Welcome Regents students to our first lab video. We're going to be doing the Pi Lab, and you've been assigned me as a lab partner. Now before I begin with the lab, I just want to explain to you that the purpose of this lab, there's a purpose, in terms of a lab purpose, a scientific purpose, but educationally the purpose of the lab is for you to practice measuring things with a ruler, which obviously that won't happen remotely like this. But also to analyze data with a graph. So you're going to be graded on how you create a graph, setting up the axes properly, how well you plot your points, how you draw your best fit line, and how you calculate your slope from that lab. So keep in mind, that's what you're going to be graded on. And as a general rule, when you're, as I mentioned in the lesson, you will be graded when you calculate the slope based on how accurately it applies to your graph. So if you're sharing analysis with somebody and you're taking their numbers to calculate the slope, they may get the answer or the question correct for that calculation. They get full points, and you might lose a lot of points because your calculation does not match your graph. So keep that in mind, that you can certainly talk to other people about how to do the lab work, but you have to process your own data. Everyone should be punching their own calculator buttons and getting their own answers. Okay, so let's jump into the lab called the Pi Lab. At this point, you should have printed out these 3 sheets. If you don't have a printer at home, I understand that we're in unusual circumstances. Then what you'll have to do is draw some of this out on a piece of paper. Unfortunately, be time consuming. Use a ruler to draw this out as best as you can, but it's in the extreme and you should be able to print it if you have a printer available. You may not be able to read what's here. That's fine. You have the sheet in front of you. So let's jump into the purpose right here. Again, we have an educational purpose, creating a graph and interpreting it and calculating a slope. But the scientific purpose is, the purpose of this lab is to determine pi experimentally. We know the answer already. We know what pi is. It's 3.14, and you could look it up, press it on your calculator, pi, and you'll get many more digits. But that's the accepted value of pi. We want to determine that with an experiment. So what we need for materials, a meter stick, 8 lids. Each lid should have its own unique letter on it. So you see A, B, C, they're all different size lids. A 55 centimeter paper band, and that's what we need for our procedure. And I'm not going to read through this because, I'm going to do it for you. So kind of reading will be tedious. You'll see the procedure as I'm performing it. So I'll set this aside. So here I have my data table. What I'm going to do is I'm going to take my first lid, lid A, and I am going to measure its diameter and its circumference. The diameter is pretty easy. So I could take a ruler and go like this, and I get about 2.99 centimeters. So let me go ahead and write that down as the diameter. Now, that's what I get for my measurement, but don't write that down on your lab sheet because I'm just showing you what happens in this lab. And then my thinking is I'm going to assign everyone their own data in a spreadsheet that you could then copy down the data from and analyze, create the graph, slope, and so on and so forth. Now, how do I get the circumference? Remember, the circumference mathematically is around the perimeter of the circle. So what I do is I use this sheet of paper and I wrap it around the lid. And what I'm going to do is create a mark where it overlaps. So just like this. And when I unroll that, I now have the circumference. So I will measure that like this. Oops. And where's my mark? Okay. 9.6 9.68 maybe, 9.68. Now I'm going to go on to my next lid, lid B. You see it's slightly larger, so it'll have both a larger diameter and a larger circumference. So that I measure like this, the diameter, and I get about 3.52. Again, you're not writing these down. You're going to get your own measurements in a spreadsheet. Circumference, I do the same way. I wrap this paper around. At the point it overlaps, I put another mark, and when I unwrap that piece of paper, once again, I have the circumference. I think it'll be more convenient if I actually go this way with my ruler. So what I have is 11.20, right on the mark, 11.20 centimeters. And I'll do one more. Okay. Oops, diameter. 4.45, okay. 4.45. And the diameter, again, I measure that by wrapping the paper around. So, try and get it nice and tight. Okay. There's the overlap. Open it up. Uh. 14.45. So if you were in class, you would repeat for all these lids, which I will do now. I'm going to pause the video and I'll take my measurements, and then I'll report those to you in a minute. Okay, so my data table is full, or I should say our data table is full. Again, I will have a spreadsheet posted for you to get your own data for your lab. But basically what you would see when you look at the information here, again, you can't see, but the bigger the diameter, the bigger the circumference. And that just makes sense by looking at these lids. The bigger the diameter, the more distance around. And that ratio, mathematically, we know is 3.14 between those two measurements. But we're going to achieve that number, hopefully, by plotting a graph. So now you're going to take your data off the spreadsheet in Google Classroom. You're going to set up these axes. Remember, as I said, you have to figure out what numbers to go up by here to capture all the circumference data, and what numbers to go by this way to capture the diameter data. Remember, diameter is the independent, so it goes on the bottom axis, and circumference is the dependent, it goes on the side axis. You number those axes evenly up to capturing the greatest data point right here. And don't forget, you need a label here. You need to call this circumference in centimeters and diameter in centimeters, and a title on your graph. You're going to plot all your points, take a ruler, put it down once to well, you could do trial and error, but what I'm saying is don't connect the dots. Once you figure out where that ruler should go, draw your best fit line, nice, crisp, even best line. I actually look at them to make sure they're straight and not wavy, that you don't draw it freehand. I'm going to look and see. I would recommend, once you plot your points and you're sure of them, go back and dot them with ink. That way, if you draw best fit line and you don't like it, you could erase the best fit line and the points will stay. And you could do several attempts till you have a nice best fit line. As I mentioned, about half the points should be above the best fit line and half below, and it should follow the general slope pattern. Here you're going to calculate the slope. Remember, there are 4 steps here. I list them here: equation, substitution with units if applicable, and the answer with units if applicable. That's actually 3 steps, but the 4th point is your scientific accuracy, that when you pick your 2 points on a best fit line. They're not close together. They're as far apart on the best fit line. That improves the accuracy of the line, or I should say the precision of the slope calculation. So when you calculate your slope, make a triangle with most or all of the best fit line. And then answer the questions here, answer the questions here. And number 3 is a bit tricky. If you need hints on that, let me know through Google Classroom. Okay, so that's the lab. It's due tonight. And also tonight you have to create an online account with the University of Texas, as you can see from your unit plan. Okay, well, thank you for being my lab partner. I enjoyed the lab, and I hope you did too. And again, any questions, let me know.